All right, my mathematicians, welcome back. We are going to be doing Unit 1, Lesson 6, talking about scaling an area. We've talked about side lengths, how you multiply it by the scale factor, distances get multiplied by the scale factor, and we discovered a couple lessons ago perimeter got multiplied by the scale factor. And in yesterday's lesson, we discovered that if you go from small to big, you're going to have a scale factor greater than 1. And if you're going from big to small, you're going to have a scale factor less than 1. And a scale factor equal to 1 gives you a carbon copy or an exact copy. So today we're going to be talking about area, and a lot of you probably think, you just multiply the area times the scale factor. Well, we're going to see if that is true or not. Now, you can use the digital version. I'm going to actually use the manipulatives that we would have used in class if we were in class. So, we're starting out with a blue rhombus, and we are being asked how many blue rhombuses blocks does it take to build a scaled copy of figure A. So here's figure A, and we want where each side is twice as long. So we're going to call the area of this 1 square unit. We're going to think about that. So I'm going to make this twice as long, but if I make it twice as long, I also have to make it twice as tall so that we still have the same shape. Okay, so there we are. So how many blocks did it take us? Well, it took us 4 to make it twice as long. Now if we want to make it 3 times as long, so I'm going to add 3 there. So it's 3 this way, but now I've got to make it 3 this way. So I'm going to add those on. So how many blocks did it take to make it 3 times? Well, it took 9. And then the last one is 4 times. So I'm going to add that 4th one here. So I'm 4 this way. Move it up a little bit. But I also need to go 4 this way. So if I add that onto it, I have a total of 16 blocks it took to build that. Okay, so twice as long took 4, 3 times as long took 9, and 4 times as long took 16. Well, let's see if that holds true with the triangles. So if I start out with one triangle, and I want to make it twice as long and still be a triangle. How many triangles did I use? Well, I used 4 of them. Well, now I want to make it 3 times. So let's see how I'm going to do this. Okay, so now it's 3 this way, but I also need to go 3 that way. Fill this in. So how many did it take? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, then we're asked to make it 4 times bigger. So we're going to have 4 across the bottom. Sure, I'm building it right here. There we go. And the last one right up top here. So 4 times bigger, it took 16 blocks once again, just like the rhombus. Okay, so now we're going to try it with the trapezoid and see what we end up with. So we're going to start with one trapezoid, then we're going to double it. So now we have 4 blocks to double it. Now we are going to triple it. Make sure I build this right. Okay, so that should be 9, 3, 6, 9, Oh, I'm seeing a pattern here. And then we're gonna go for 4. Turn this that way. Turn this that way. Kind of falling apart here. It's gonna go in here. That's going to go in here. Let's see, then I'm going to go across here. Oops, that one's got to go upside down. All right. So now I have, let's see, that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 blocks. All right, do you see a pattern? Well, when I used a scale factor of 2, I ended up using 4 blocks. And if we think of this as area, when we were here with one trapezoid, it had an area of 1 square unit. Well, if I increase it by a scale factor of 2, I end up with 4. When I increased it with a scale factor of 3, I ended up with 9 blocks. So if we think of that as this is the area, it took 4 blocks squared, unit blocks, and this went to 16. So what did I do to the 2 to get to 4? Some of you are probably saying I multiplied it by 2. But if I take 3 times 2, I don't get 9. Did I raise the 2 to the second power? Did I raise the 3 to the second power? Did I raise the 4 to the second power? All right, so thinking about that, make a prediction. How many blocks would it take to build scaled copies of these shapes using a scale factor of 5? Well, if I take the 5 and square it, it's going to take me 25 blocks. How about 6? 6 squared, it will take me 36 blocks. So looking at this, how is area affected by the scale factor? Well, it's not multiplied by the scale factor because the area of the very first one was 1, and now the area is 9. Okay, so we took the scale factor, we didn't multiply it by 3, we multiplied it by the scale factor squared. So the original area gets multiplied by the scale factor slide this over, squared, and that is going to equal the copies area. Okay, so that's what we discovered. Now, if you'd like to do this one, you can use the interactive right here, that to do it, but you don't have to if you don't want to. We are going to jump to activity 3. And in activity 3, you're going to be given 2 shapes. Let me find my 2 shapes. Oh, here they are. Okay. So if we were in class, one of you would get this one, your partner would get this shape, and you would answer these questions. So what we're going to do is I'm going to do both shapes. So we're going to start out with this parallelogram, and remember the formula for area of a parallelogram is base times the height. So if we have a base of 5, and a height of 2 because the base and the height occur at the right angle. If we multiply the base times the height, we get an area of 10. All right, now if I make this twice as long with a scale factor of 2, so 2 times 5 is 10, 2 times 2 is 4, so I have multiplied this by, to go from here to here, I've multiplied it by 2. 10 times 4 is 40. So what did this get multiplied to go to here? It got multiplied by 4, and we're going to think of that as 2 squared, the scale factor squared. All right, so let's look at if we make that parallelogram with a scale factor of 3. Well, that means we take the base and we multiply it by 3, we get 15.